Good morning, everyone. I'm Cadet Captain Anthony Perez, and today we're going to be taking a look at an introduction to networking. So, what is a network? A network is just a way to share information between devices, and there are different classifications of networks for the different size of networks, both geographically and how many devices they have. The first type is going to be a PAN, a personal area network. This is basically everything you're going to have on your person. So it might be your phone, it might be some Bluetooth headphones, it might be a laptop, it might be just whatever that you'd have on your person. The network that connects all of those would be considered a personal area network. Moving up a scale, we have a local area network, and that's essentially what's in your house. So you got your modem, you got your router, you got a couple computers here and there. You got maybe a TV, maybe you got some IoT devices such as a garage or like a smart doorbell, so on and so forth. And if you think about it, a LAN is made up of PANs, and you're going to see the theme moving forward. So if we move to campus area network or a CAN, you can think of a school or you can think of an office building or the like. And then moving one up, we see a MAN, a metropolitan area network, and you can think of it as your town or your city, etc., etc. And if you think about it, a MAN is just a bunch of cans that are connected, and a CAN is just a bunch of LANs that are connected, and a LAN is just a bunch of PANs that are connected. And then moving one up to the widest area network that has a definition, or rather classification. We have WAN, wide area network, and you could think of this as the internet. It connects a bunch of MANs together. Usually, the geographic region for this is really large, spanning multiple countries and multiple continents. A pretty good example of this would be the internet. So, in the early days of networking, think like the 70s, the 80s, and even up until the 90s, everyone had their own proprietary standards for networking. So if you wanted to add some networking equipment, you essentially had to build it yourself to work with your own little implementations of networking. But eventually, two standards were created, the OSI model and the TCP/IP model, and eventually we've settled down to mainly use the OSI model, but the TCP/IP model is also somewhat relevant and is occasionally used here and there. So I do recommend being somewhat familiar with the TCP/IP model, and then also pretty familiar with the OSI model. So what the OSI model does is it breaks up networking into separate layers. And then you could refer to that moving from the top up as layer 1, 2, 3, 4, 5, 6, and 7. And this is a little tidbit when it comes to troubleshooting. When you troubleshoot something, try and start on the lowest level that you can. And as soon as, or actually in the next slide, we're going to talk a little bit more in depth on each of the layers so we can actually understand why that's applicable. So if we start at layer 1, this is the physical layer. The this is the wires in the Ethernet. This is the pulses of electricity going through it. This is the silicone on the chips, etc., etc. This is what you can touch. And then moving up, we have layer 2, which is data link, and this is where the MAC address resides. The MAC address is something that you are definitely going to want to know where it's located in the OSI model moving forward. Next up, we have layer 3, which is the networking layer, and it includes stuff like IP or Apple Talk or IPX. And these are ways of giving computers names, essentially. That's not assigned by the manufacturer. So definitely IP is another one that you are going to want to know where on the OSI model or what layer it resides in. Next, we have layer 4, which is transport. In other words, how does it get from my computer, Google, and back? And how do we know that all the packets got there and they were unchanged? That is the responsibility of TCP UDP. Moving up another layer to layer 5. Layer 5 is the session layer. Not too many people get in depth to the session layer, but what the session layer does is it creates a session between a host and a client, and it maintains that session, and then eventually at the proper time it cuts that session off. Moving up one further, we have layer 6. Layer 6 is the data representation layer. This is, you can remember this as it's just the file extension. It takes the data and puts it into a format that you can transport over the network. So you can think of like a .csv, a .txt, .jpg, a .gif, .tar, .zip, whatever. It's just file extensions. Then the highest layer, we have the application layer. This is the HTTP, this is the FTP, this is the www, the HTTPS, etc., etc. This is what applications use. And if you notice something, it might be on the next slide. It's not on the next slide. So every layer is dependent on every layer below it working in order for that layer to work. So if we look at data link, right? No data can be transmitted if your wire is cut. And FTP is not going to work if your wire is cut, right? Or there's some corrosion that makes it transmit irregularly. And no FTP is going to work if you don't have an IP address, right? No websites are going to work if your session isn't created properly. And no apps are going to work if the .html file is improperly formatted. Your browser is just going to get it and go, what? And probably give you an error. So this is where we go back. So when troubleshooting, start at the lowest possible layer. So if you're troubleshooting, say, a networking issue, right? You can't reach a website. The first thing that you're going to want to check is the lowest layer that you can check. Usually that's the layer 1 or physical. You make sure all the things are plugged in. Next, generally you don't do too much checking at layer 2 because you can assume that they have a MAC address. If they don't have a MAC address, then the manufacturer messed up big time. But that is something that you could check. And moving up to layer 3, this is probably the layer that encounters the most issues. Do I have an IP? Is that IP on the correct subnet, which you'll learn about probably quite a bit later? Does that IP have a route to the website? Is that website responding? Or does that website have an IP? Can it respond? Is there a gap in the middle, or what's happening with that? And then if everything's good there, is there something with your transport? Is your TCP window misconfigured? Et cetera, et cetera. And you just keep going up until you find whatever the issue is. Yeah. Alrighty. So let's talk about a little bit more about MAC address. If you remember, MAC address is on the second layer, layer 2, and a MAC address is, you can think of it as a computer's fingerprint, right? Every MAC address for every device is unique to that device and that device alone. So a MAC address is 48 bits, and you can see it here as 6 pairs of characters, and those characters are 1 through 9, A through F, because they are hex characters. Yep, 12 hex characters separated, and they can either be separated by a semicolon, a colon, or a dash, or even a forward slash. I've seen it in some cases. And yep, it's assigned by the manufacturer. It's ingrained in the chips in the network interface card, which is either your Ethernet card, your Wi-Fi chip, just however you're connecting, that has been assigned a MAC address. And the first half of it, so the first 3 pairs, are what's called the organizationality unique identifier, or the OUC. And it represents what manufacturer makes it. So for example, an OUI of 000D4B, all devices with that OUI, and the OUI is again just the first 3 pairs, all devices with that OUI were manufactured by Roku LLC. And that's the same with every other MAC address. So you can use the first 3. Maybe it was made by Google, maybe it was made by Facebook, maybe it was made by HP or Qualcomm, just whatever. It'll tell you what manufacturer made that NIC. And then the last 24 bits, or the last 3 sets of characters, are what's going to be unique to that device and that device only. Now, the way that Mac works is, I'm not going to get too in depth into it, but in long story short, you can spoof it very easily. And thus, Mac based security is inherently insecure because of how easily you can spoof it. And a common implementation of Mac based security is something like hotel Wi Fi, right? So when you log in with your credentials, all it does is take your MAC address and then whitelist it. So if you were able to spoof someone else's MAC address, then you would be them on the network, and you would have access just fine. As this is the same with all Wi-Fi, not just hotel Wi-Fi. That's just the example that came to mind. So again, Mac-based security is inherently insecure, but you should still implement it. Maybe you might weed out some script keys or something. IP addresses. IP addresses are layer 3 on the OSI model, and there are actually 2 versions of IP. So there's IPv4 and there's IPv6. IPv6 is 128 bits compared to the 32 bits of IPv4. Due to the complexity of IPv6, we won't be talking about it. We will, at least for now, we will only be talking about IPv4. So IPv4, as previously stated, has 32 bits and is separated by periods into 4 octets of 3 characters each. So there's an example, and the minimum octet value is 0 and the maximum is 255. So if you ever have something above 255 in any of those, whoever built the network either messed up big time or that's not an IP address. And a aspect of IPv4 is because it's so small, we're actually running out of IPv4 addresses, which is why IPv6 was created and we are slowly shifting to. And another thing that was created to slow down how fast we are running out of IPv4 addresses is that we have IPv4, or we have a couple ranges that are routable. This means that they can be transmitted over the internet. They won't be blocked by your ISP. And then there are also non-routable or private IPs. These IPs will be dropped by your router if they're going essentially to the internet, or your ISP will block them. Yep, routable ISPs are assigned to you by your ISP, and you should not use those on your internal networks unless it's a segregated network. So if it's connected to the internet, then use a private IP. If it's not connected to the internet, then you can do whatever you want. So the non-routable IP ranges are those. And again, notice how none of these digits go below 0 or above 255. Yes, and so if, let's say I have a network of 192.168.0.1, that's my network for my home, or that's the network that my home network uses. And let's say there's someone else who also uses the IP, or uses the network of 192.168.0.1. This is not a problem because I cannot reach 192.168.0.1 over the internet because the ISP blocks that. And there's also features on routers where they'll just drop it before it gets to the ISP. But routable IP addresses, all of those, you can reach those addresses from the internet. And these addresses should only be used either assigned by an ISP or a lab that is segregated from the internet. And there are some special IPs that are in those ranges previously specified. So 127.0.0.1 is a loopback IP. So if a machine wants to connect to itself, it will use this IP address. So long story short, don't use this IP in an actual network. And also the 255, 255, 255, 255, which is broadcast. And this is used when a machine wants to talk to all the other machines on the network. So this is common for something like a DHCP server, which is a server that hands out IP addresses to new clients. So when a machine joins the network, let's say it's, I don't know, Wi-Fi, when they join the Wi-Fi, they'll go, hey, I need a DHCP server, and it'll broadcast a discover packet to everyone on the network. And then eventually the DHCP server, they'll get it, they'll send a packet, the host will send a packet, or the client, and it'll just go back and forth until they have an IP address. No, I believe this is the last slide. Yes, it is. We're just going to talk about networking equipment real fast. So hubs, they work on layer 1, and if they receive a packet, they are going to forward that packet out every other port. Now, this is neither secure nor efficient nor effective, and as such, best practice says to not use hubs ever. And then next up, we have switches, which work on layer 2. And if you remember, layer 2, MAC addresses also work on layer 2. So switches operate based on MAC addresses. So if you needed to contact another computer, it would use MAC addresses to get there and MAC addresses to get back. No IPs are ever used on a layer 2 network. Then a layer 3 network. This is where your IPs come in. And routers are going to be the ones to handle IP addresses and routing between networks. And there are such things as layer 3 switches that can handle the routing of packets between networks, but uh, it's a very specific use case that we won't get for a little bit. All right, so that about covers it, I believe. Yep. So that was intro to networking. I hope you learned something in this lesson. I hope to see you in the next one.